This is chapter 8, question 12. It says experimental tests have shown that bone will rupture if it is subjected to a force density of 1.03 times 10 to the 8 newtons divided by meters squared. Suppose a 70-kilogram person carelessly roller skates into an overhead metal beam that hits his forehead and completely stops his forward motion. If the area of contact with the person's forehead is 1.5 centimeters squared, what is the greatest speed with which he can hit the wall without breaking any bone if his head is in contact with the beam for 10 milliseconds? What a question. This is great. This is fantastic. Um, all right. So we will take our impulse. We're going to take a couple equations, redo them, back them together. It'll be great. So impulse equals force average times delta t, and your average force can be changed to force density times area. So force density, and then that's P. So your P is force density times area times delta T. And then we can take our change in P equals your mass times velocity final. Initial P equals mass times final velocity. Yep. Now we can set these equal to each other. Your impulse here and your impulse there. So impulse is the change in momentum. So your delta P is your I. So now we can do M VF minus M VI equals PA delta T. For the sake of convenience, we're going to take our M's out. Because what we're solving for here, so it's not convenient. We have to solve for your initial velocity. So how hard you can roller skate into a metal beam. Yeah, so we have to solve for initial velocity. Divided by M, subtract VF. And then we'll need to flip all of our signs. So this would be negative and then we positive. And then you come out to your initial velocity equal negative PA delta T for M plus VF. Or I guess I could just VF minus all that stuff. Now we have all of the information we need for this. So your P is 1.03 times 10 to the 8. Yeah. Times 10 to the 8. Your A is 1.5 times 10 to the negative 4th. And then your time, your delta T from start to finish can only be 10 milliseconds, which is 10 times 10 to the negative third. Put that over our mass of 70 kilograms. And then we need to add our final velocity, but that's just 0. So you don't need to add it in. When you put all that in your calculator, you come out with 2.21 meters per second. I'll write it. So this is how fast you can rollerblade into a wall or into a beam if you weigh 70 kilograms without cracking your skull. So that is great. Physics is great. Good times.